Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to start a review of Danica McKellar's Hot X Algebra Exposed book. Yes, I've got a copy of it right here, and I'm going to review it chapter by chapter, just like I did with Danica McKellar's Math Doesn't Suck book. But before I begin, I wanted to let everybody know that I have published 5 Kindle books. If you want to read any of them, leave me a comment down here in the comment section below, and I will be more than happy to send you a hyperlink to those books, and you can read them for yourself. Furthermore, if you want to make this video very, very popular, there are 2 things you can do. Number 1, you can leave me a nice comment in the comment section below, or you can actually watch this video all the way through to increase the watch time and cause it to be more popular. And there are links at the end of this video that will take you to other parts of this video series, so if you want to go to the next section, you can. Alright. Now, I'm going to begin this review with the etymology of the word algebra. The word algebra comes from the Arabic prefix al, which is just like the English article the, and the Arabic phrase, and I'm not going to read this phrase, I'm going to actually put it as a section in the description of this video so you can read it for yourself. What does the phrase mean? In order to comprehend the meaning of this phrase, you have to know the meaning of the word compendium. The word compendium means a summary or a list of things. This word has various uses. So you have a summary of calculations. But how did you achieve this summary of calculations? You used restoration and balance to achieve this summary of calculations. If you find this definition complicated, feel free to research the topic further. Okay? Alright. In the introduction of Danica McKellar's book, Hot X Algebra Exposed, she states that she never saw herself like the male geek classmates that were in her class. What a stereotype! I never saw myself like them either. You didn't see me wearing suspenders, and you certainly didn't see me with pocket protectors either. And did I have any tape on my glasses? I didn't have duct tape on them either. Doesn't Danica McKellar realized that many of these geeks found themselves unemployed due to their overconfidence in their intellect? Give me a break. You really want to aspire to be like them? Some of them succeeded, but not very many. They became so arrogant and overconfident they kind of lost. You don't have to look like a geek to think like a geek. And that's thanks to Harry Lorraine. And I know the mere mention of that name on my channel sounds like a broken record at this stage of the game, but without mnemonics, no one can truly comprehend mathematics. This is impossible. The next thing I want to do is directly address the geeks that may be watching this video right now. Let me tell you a story. Long ago, there was this lady who saw a stray kitten on her porch. She gave the kitten a saucer of milk. The kitten came to her porch the next day, and the lady gave this kitten another saucer of milk. And she did this day after day until finally she just adopted the kitten. Well, that's a beautiful and wonderful story, and a lot of gals, a lot of young ladies and ladies just love stories like that. That's fine, to a point. Okay? But what if we replace the kitten in this story with a homeless person? Is this so cute of a story now? You really want you want to adopt a homeless person? I don't think so. So if you don't want a bunch of homeless people showing up to your porch every day, I would suggest you share this video with all your friends and tutor your friends, just like I'm going to show you how to do today. And make sure that when they watch this video, they share it with their friends as well. Because you don't want a bunch of homeless people showing up at your front doorstep. And that's exactly what's going to happen if you don't listen to me. And more importantly, stop looking like geeks. Look, if you need a new pair of glasses, get a new pair of glasses. And take care of your glasses a little better, alright? Don't be doing some of the stunts you guys have been trying to do. And furthermore, no suspenders. Give me a break. Find another way, or at least hide the suspenders so nobody actually sees them. And quit with these pocket protectors, okay? Modern pens don't leak like that. And if you need a modern pen, put it in your pants pocket instead of your shirt pocket. That's what I do with mine. That's not nearly as geeky. They don't see it that way. If it leaks in your black pants pocket, it's not going to show up anywhere anyway. If you're going to wear shirts, wear a darker colored shirt so it don't show up so well. Okay? Look, you don't have to look like a geek, to act like a geek, to sound like a geek, or anything else. And you don't even have to sound like a geek either. It's ridiculous. You can learn as much as you want to, and you can even share what you know with all your friends, but you have to do it in a non-geeky way. Okay? And with plastic lenses, usually you don't need big, thick glasses, and you don't have to have duct tape glasses either. So, you know, take care of your glasses a little bit better. According to Danica McKellar, this book is filled with pastries and candy. You want to give these people diabetes? You want them to be obese the rest of their lives? Maybe we should cut back on the sweets in this book. I mean, I'm as much of a fan of sweets as anybody else, but you keep that up, and they're just going to be obese and have some medical problems on top of it. So, I will tell you though that the puppies were a nice touch. Okay, and granted, I love celebrations. But if you're going to have a celebration, you might want to bring some sunscreen. Especially you're talking about a pool party. Yeah. Like I said, what are you trying to do? Wait for the geeks to show up and bring the sunscreen along with them? And I guess these young ladies will have to visit their hair salon after swimming in the pool. Think about that for a second. And after all, I mean, that pool contains chlorine, and they're going to have their hair treated after that. And they might even want to treat it before they pop in the pool. Okay? I wonder if they have enough money for that. And let me ask you something. Are these ladies that you're writing about in this book, are they wearing costume jewelry or real jewelry? Okay, you might have to be a bit more responsible. You're wearing real jewelry. That stuff's expensive. As far as I'm concerned, there is no such thing as pre-algebra. I know they market that all the time. It's really just mathematics. They should have taught you in elementary school. Let me tell you something. I never took a pre-algebra class. I went straight from elementary mathematics straight into algebra. There was no need of pre-algebra anything. That's a waste of time. And after you watch a bunch of my videos, you're going to find out just how much of a waste of time that is. Okay? Alright? Alright. By this point, you should already know about factors, fractions, decimals, negative numbers, exponents, slope, graphing, and so much more. And I will cover these topics much more thoroughly in future videos. So stay tuned for that. Before I continue, I want to point out a couple of things. The first thing I will say is you don't have to travel to an amusement park to learn algebra. Save your money and pay attention to what I say in this review. The next thing I will point out is that variables are just simple numbers cloaked in ghost sheets. Have you ever had a Halloween time where you put a sheet over you, cut some eyes out, cut a mouth out, and you were a ghost for Halloween? Same concept. Duh. What is it that I see at this amusement park that she wants us to visit? I am touring Danica McKellar's amusement park, and I've just walked past a kissing booth. Do I really want to kiss the variable in that booth? Well, since I can't see what's underneath that ghost sheet, I may be a little bit hesitant about this. Okay? And I have absolutely no intention of using emojis as representations of variables. It may be cute, but it's totally unnecessary. We want to get through this stuff quickly, not be cute. Alright? We want to spend less than 20 minutes on mathematics and get on with our lives. So Danica McKellar has decided to define the word constant and coefficient. Well, I guess I'm going to have to give you the etymology of both words. The word constant is not a squishmallow. This word comes from the Latin prefix com, which means together, and the Latin word stare, which means to stand. So the constant in an equation is some number that stands together. Just imagine a group of people standing together. When you're dealing with a constant, you can imagine that you know how many people are standing together. What about the word coefficient? The prefix co comes from, of course, the prefix com, which I just defined. The word efficient comes from the Latin prefix ex, which means out of, and the Latin word facere, which means to make out of. Get it? So imagine that all coefficients are factories that produce products in an efficient manner. Okay. Are we getting this so far? It would have been nice to have seen all that in Danica McKellar's book, but it's not there. I looked. Trust me. What else does Danica McKellar say in the first chapter of her book? She defines the word term. I'm not fond of her definition, so I give you my own definition. Just imagine that all numbers of variables on the left or right side of a plus sign, a minus sign, a multiplication sign, or division sign is a term paper. And you have to read the term paper to get a good grade. Okay? Now, so, this is a mathematical term, this is a mathematical term, that's a mathematical term. That's what I'm trying to tell you. Just imagine, this is a term paper, this is a term paper, and that's a term paper. Easy to remember. Let's go on. Alright. Now, in this math problem, everything on this left side of the equation is going to have the same value as everything on this right side of the equation. That's why it's called an equation, okay? Because of the equal sign. If you subtract 8 from 15, you'll have 7, and 7, of course, equals 7. You can think of the equal sign here as like a seesaw, or, to give you a better illustration, of a pair of scales. Think of the equal sign as a pair of scales. The middle of this scale is the equal sign. This is the stuff on the left of the equation. This is the stuff on the right. I'm so glad I kept this. Oh. That's why I keep stuff like this. Helps you visualize things. Now, you don't need people who project a different aura around them to solve a mathematical equation. You need a pair of scales. There you go. She's making this too complicated. It's a lot of visuals, and that's good, but the visuals just really don't apply here. Okay, now, Danica McKellar is correct in saying that if you multiply the numerator and the denominator of a fraction by the same amount, okay, we multiplied the 2 by the 2 and we multiplied the 6 by the 2, that you're going to get the same value, because 4 divided by 12 is 1/3 and 2 divided by 6 is 1/3 as well. Same value. So you can multiply the numerator and the denominator of a fraction with the same number and still get the same value. That's the way it works. So I will agree with her on that. The next term I need to cover, and I need to give you the etymology of it, is the word equivalent. It comes from the Latin word equus, which means equal, and the Latin verb valere, which either means to be well or to be worth something. So equivalent numbers have self-esteem only when they are of equal value. That'd be easy to remember. Why should mathematics be afraid of anyone? And why should any of you be afraid of mathematics? No reason at all. The only reason why you should be afraid of mathematics is when people teach it to you poorly. Well, I'm teaching it to you a lot better, and you can clearly see that. So, don't be afraid of mathematics. Stick with me. I'll get you through. Okay? Either you're being taught mathematics by a poor teacher, or you're being taught mathematics from a poorly written book. If you're watching this video, you're probably aware that I started a discussion of Koine Greek letters. You will see these letters as you approach the topic of calculus. So at this point, it's important to visualize variables as letters. Why? Because you're going to see a lot of Koine letters in calculus equations. Alright. Now I want you to take a look at something. You're going to love this. So we have 6. Okay, 6a, which is alpha, 6 alpha, plus 7 beta, minus 5 beta, minus 3, I'm sorry, 5 alpha. Let me do this again. Let me do this again so you can see it. 6 alpha plus 7 beta minus 5 alpha minus 3 beta. You're going to see equations like this in calculus. That's why you need to understand variables. Because you're going to be taught Koine Greek letters, and I'm already beginning to teach you that. And you need to know them. Alright? Now, if you watch my video series showing you every single Greek letter, you'll get this. As I stated below, the letters A and B are variables. This would be the letters alpha and beta. And you know that these variables are wearing costumes. These costumes are hiding the numbers wearing the costumes. But I think at this point you know that since the letters are different, then the numbers that the variables are covering are also different. Now, at this point you may want to add or subtract or multiply or divide the coefficients. Alright? Now we already know that 6 alpha and 5 alpha have the same variable. You can now subtract the coefficients. As long as these variables are exactly the same, you can do this. So 6 alpha, well, that's a terrible alpha. Minus 5 alpha equals just simply alpha. 6 alpha minus 5 alpha, it just equals alpha. That's all it is. Now, why can't you subtract the 6 from the 7? Or why can't you add the 6 to the 7? Or why can't you subtract the 6 from the 3? Because the variable A and the variable B are different. You just can't do that. Okay? Now, you can also have 7 beta and subtract 3 beta and have 4 beta. And there you go. Because the variables are exactly the same, you can subtract the coefficients. But you're going to see this in calculus and you need to know it. Alright. So, what would you have as the final equation to this particular problem? Well, what you'd have is alpha plus 4 alpha plus 4 beta. Of course, since you don't know what numbers are being covered up by alpha and beta, you would never be able to solve the whole thing. Okay? Now the next rule is very simple. If you multiply a fraction by a whole number or a variable, then you multiply the numerator by a whole number or variable. So, let's say you have this fraction right here, 2x over 5. What you do is you multiply the 2 by the x. So now you have a fraction 2x over 5. Anytime you see a coefficient like this and you see this, always multiply this by the variable, by the numerator. Multiply the coefficient by the numerator. Always. Okay? Ignore the denominator at that point. Okay? Because what they're doing in essence is it's more like 2 over 1 multiplied by x over 5. So you multiply the 2x and you multiply the 5 and the 1. Okay? Alright. What about the commutative property of mathematics? Remember, the etymology of the word commutative is the Latin prefix com, which of course is with or together, and the Latin word mutare, which means to change together. Think about all those science fiction movies where people are mutating into other creatures. Or you can think about commuting to your friend's house, or your friend commuting to your house. Just because you travel to another house doesn't mean that you or your friend changes. It just means you're traveling to a different destination. This works well with addition and multiplication. Okay? Let me illustrate this. If you add the 5 and the 2 together here, that's going to make 7. And if you add the 2 and the 5 together here, it makes 7. It doesn't matter which order those numbers are in. That'll work. It'll also work with multiplication. Okay? So, if you were to shift the addition to multiplication, okay, dot here, dot there. 5 times 2 is 10, and 2 times 5 is 10. Same thing. It will not work with subtraction or division. You flip the number around like that, it won't work. What about the associative property? It works well with addition and multiplication. The etymology of the word associative comes from the Latin prefix ad, which means to or toward, and the word sociare, which means to unite with, and that's another Latin verb, okay? In this case, no matter what numbers associate with other numbers, the final answer will be the same. So let me illustrate. You could have 5 plus 3 plus 4. Okay? Now 5 plus 3 is 8, and 8 plus 4 is 12. But if you were to add 5 plus 4, that would be 9, and plus 3 would be 12. Or if you added 3 plus 4 together, that would be 7, and 7 plus 5 is 12. It doesn't matter in which order you add these things in, as long as it's added together like this. Same answer. Multiplication, same way. But it will not work for subtraction or division. Only addition and multiplication. The distributive property should be easy to deduce. Just imagine distributing cookies to children. You want to make sure each child gets one cookie, because otherwise those kids are going to fight with each other. You don't want that. I want you to research the distributive property on your own time, because it's going to be a rather lengthy video here. The next topic Danica McKellar The next topic that Danica McKellar briefly discusses is the word problems. In the not too distant future, I don't know. I lost that one. But anyway, she discusses something else. Okay. At this point, I have to pause this review because of the next topic Danica McKellar covers. She briefly brings up the topic of poor reading. Why do people read poorly? Because no one has been taught how to speed read. That's why. And one of the foundations of speed reading is storing a dictionary in your head. It's not impossible to store a dictionary in your head if you know Harry Lorraine's memory techniques and you know mnemonics. I covered this on my YouTube channel more than once. And I have also stated more than once to never get into debt. If you follow my advice, you will never need to calculate interest rates on a credit card. You might have to calculate interest rate on somebody else's credit card, but it won't be yours. And I wonder when Danica McKellar ever read the United States Tax Code. This is a topic I may cover in future videos. Be interesting, don't you think? Then Danica McKellar mentions the word integer, but she doesn't take the time to clearly explain the math term. But of course I will do that myself. The word integer comes from the Latin prefix in, which means not, and the Latin word tangere, which means to touch. The first thing you should notice is that the verb tangere looks very familiar. Ever heard of a mathematical term called tangent? But let's return to the math term integer. The math term integer literally means to touch not. So in this case, it means a whole complete number. At this point, you may have noticed that the integer numbers are sometimes represented by the letter Z. This is no ordinary Z. This is the Roman letter Z, but it looks really funky. It comes up like this, goes across like this, comes down with like this, and then it goes across like this, and that's approximately how it looks. Now this represents a set of integers. It doesn't just represent one integer, but a whole set of them. This looks like a Koine Greek letter, but it's actually a Roman letter. Okay? It is actually the first letter in the German word Zahlen. The German word Zahlen means number. Okay? Why are integers represented by the letter Z? That's a question you should ask David Hilbert, because he'll give you the answer. So far, my basic research has revealed that the letter Z represents a set of integers. I also discovered that the letter Z comes from the Latin alphabet. I will trace down this a little bit better in a future video. The next word I need to cover, oh my gosh, I have to cover so many of them, in this review is the word consecutive. Obviously, this word has a Latin prefix, con or com, which means together. But this word also contains the Latin noun sequi, which means to follow together. The word consecutive, therefore, is some kind of a number sequence. And the topic of number sequence leads to the number sequence leads to the Koine Greek letter delta. I should have said sigma. Sorry. It leads to the Koine Greek letter sigma, which I covered in a previous video. I will concur, however, with Danica McKellar that number sequences in mathematics are represented by equations like n plus 1 or n plus 3. You've seen things like this before. And if you've dealt with the Koine Greek letter sigma, you've seen this. Finally, we get to the end of this first chapter, and she references dancers and soccer players, which, at this point, I will actually agree, practice makes perfect. I agree with her on this. Alright? Woo! Well, I hope you enjoyed this particular presentation. I hope that the rest of the presentations she has in this book will not be nearly as long, but we'll see. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.